Find all vertical asymptotes and create a rough sketch of the graph near each asymptote. So we're looking for vertical asymptotes on this example. So to find vertical asymptotes, we need to write this function in factored form, and the numerator is x plus 6, which is already factored. Denominator is x squared minus 36. This is a difference of squares. We can write this as x plus 6 times x minus 6. And once we write it in factored form, we need to look for common factors. We do have a common factor here. And so what that means, if we have a common factor, that means that we're going to have a hole in the graph. And we can find the hole by setting that factor equal to 0. So this function will have a hole in the graph at x equals -6. And then this remaining factor that doesn't have a common factor will be a vertical asymptote. We can find that vertical asymptote by setting that factor equal to 0. So we have a vertical asymptote at x equals 6. So this function will have a vertical asymptote, just one vertical asymptote at x equals 6. And then we want to create a rough sketch of the graph near each asymptote. So we want to create a sketch of the graph near that asymptote of x equals 6. So I'm going to draw my horizontal axis, which is the x-axis, and mark out at 6 a vertical asymptote. So I'm drawing a little dashed line to represent the vertical asymptote. And we need to remember the definition of that vertical asymptote. As x approaches that value of 6, the y is either going to approach infinity or negative infinity. And we need to consider this on both sides of 6. So we have a special notation that we use to indicate each side of 6. So if we want to say numbers that are less than 6 or the left of 6, we put a minus, and x approaching 6 from above 6 or to the right of 6, we put a plus. So this is going to take care of what's happening on each side of 6. But we know that the y will go to infinity or negative infinity, but we just don't know which one. So we don't know whether we should sketch the graph approaching infinity or negative infinity from above, or if we should approach infinity or negative infinity from the below. And so that's what we need to figure out, which way we should sketch it. So the way we figure it out is with a test value. We want to pick a test value that qualifies for above 6 and a test value that qualifies for below 6. So we could pick, we really want to pick something that's close to 6, so maybe we pick 5.9 and 6.1. We substitute those values into our function and look at the sign. And the sign will tell us whether we're going to go to positive infinity or negative infinity. So we're going to do x and y. We're substituting in 5.9 and 6.1. 5.9 plus 6 over 5.9 squared minus 36. 5.9 plus 6 is a positive number. 5.9 squared is 34.81 minus 36. So 34.81 minus 36, that's a negative value. I'm going to erase this so I can keep writing. So that is a negative value. A positive divided by a negative will give me a negative value. So what that tells me, remember that 5.9 was the number below 6. Because this came out to be negative, that tells me that y will be approaching negative infinity on that side. So that tells me that when I sketch the graph on this side, my y will approach negative infinity. Then I'll do 6.1. 6.1 plus 6, that's a positive. 6.1 squared minus 36. 6.1 squared is 37.21 minus 36. That's a positive. Positive divided by a positive will be a positive. So remember, I chose this 6.1 to be above 6. That plus indicates that I'm going to go to positive infinity. So now I know that y is approaching infinity from above. So I know when I sketch, I'm going to draw it going to positive infinity. So I'm going to zoom out just a little bit. I'm going to draw the sketch one more time without so much clutter. So at 6, that's a restricted value. We know there's a vertical asymptote at that value. Y will approach positive infinity when we're above 6, and y will approach negative infinity when we're below 6. For this question, we want to find all vertical asymptotes and create a rough sketch of the graph near each asymptote. But when we're looking for vertical asymptotes, we need to first find any restrictions we have on this rational function. So we're going to do that by setting the denominator equal to 0. We set that denominator x squared minus 11x plus 28 equal to 0. And we can solve this quadratic equation by factoring. X times x would give us the x squared. 7 times 4 will give us 28. And we need both of these to be negative to create that negative 11 in the middle. And we can set each of these factors equal to 0. And that gives x equals 7 and x equals 4. So this rational function has some restricted values at 7 and 4. But those restricted values might not be vertical asymptotes. They could be vertical asymptotes, or they might be something called a removable discontinuity. So we need to check to see if this function has any common factors. The numerator is already factored into x plus 6, and the denominator, we factored that into x minus 7 times x minus 4. And you can see that we do not have common factors between the numerator and denominator. So that means that both of these are vertical asymptotes. So this function has 2 vertical asymptotes. And then we want to draw a rough sketch of the graph near each asymptote. So there are a couple ways that we could come up with this rough sketch. One of them is with something that we call a sign chart. So what we're going to do is we're going to draw a number line. And on that number line, we're going to put all of the factors, or not the factors, the zeros of the factors from the numerator and denominator. So we already got the zeros for the denominator, that's 7 and 4, but we also want to use the 0 from the numerator as well, which would be negative 6. We're going to put those numbers on this number line. That's negative 6, 4, and 7. I'm making sure to put them in order from smallest to largest because our number line goes from left to right, smallest to largest. And over here, I'm going to list the factors that we have. We have x plus 6, x minus 7, and x minus 4. Let me draw a little grid for these different factors. The one thing about these factors is that they are all linear factors. They all have a positive slope. So when a linear factor has a positive slope, the graph will change its sign. So on the left here, all the y values are negative. So that's to the left of your x-intercept, or 0. And to the right of your x-intercept, all the y values are positive. So I can make this sign chart based on that information. So let me draw. I'm going to draw little vertical dashed lines on all of these numbers to separate out my number line. And for this factor of x plus 6, it has a 0 of negative 6, and it will change signs over that value. That value is the 0. So remember we said here it changes signs over the 0 or the x-intercept. So it's going to be negative to the left of that 0, but positive to the right of it. Then the next factor is x minus 7, which has a 0 of 7, so it's going to change signs over that 0. It will be negative to the left of it and positive to the right of it. Then we have a factor of x minus 7, which, oops, I wrote the same factor twice, so this should be x minus 4. And x minus 4 has a 0 of 4, and it will change signs over that 0. So to the left of it, we have negative, and to the right of it, positive. So we do that for each factor, and then we're going to multiply all the signs together. So if I multiply these three signs together, a negative times a negative times a negative will be a negative for that interval. We multiply these three signs together. A positive times a negative will be a positive. We're going to multiply these three signs together. A positive times a negative will be a negative. A positive times a positive will be a positive. Okay, so let me explain why we did all that work. We have our asymptotes at 4 and 7. And now I know that to the left of 4 we have a positive, and to the right of 4 we have a negative. So that's going to tell me that the y is going to go to infinity on the left and negative infinity on the right. And for my vertical asymptote of 7, I now know that on the left is a negative and on the right is a positive. And so on the left, the graph will go to negative infinity, and to the right will go to positive infinity. So if I were to sketch a graph near these vertical asymptotes, here's my coordinate plane. I'm going to mark 4 and 7, put vertical asymptotes at 4 and 7. To the left of 4, I'm going to positive infinity. To the right of 4, to negative infinity. To the left of 7, to negative infinity. To the right of 7, positive infinity. So that gives me a sketch near those asymptotes. So I showed you how to get those pluses and minuses from the sign chart. But if that is confusing or maybe too much work, you can also choose test points. So let me just get a different color here. So I could choose test points on either side of my asymptotes. So I want to choose a number that is smaller than 4, so maybe 3.9. And I want to choose a number that's bigger than 4, maybe 4.1. And I'll choose a number that is smaller than 7, 6.9, and a number that's bigger than 7, 7.1. And if we substitute these values into our original function, we should get the sign as well. So we can substitute f of 3.9. Let's get our calculator out to make this more convenient. Okay, so I've got my calculator here, and I'm going to substitute into the numerator 3.9 plus 6 divided by 3.9 squared minus 11 times 3.9 plus 28. And all we need to pay attention to is whether we get positive or negative, and we got positive. And that matches what we saw on our graph. Then we do it again for 4.1. So we have 4.1 plus 6 divided by 4.1 4.1 squared minus 11 times 4.1 plus 28. This time we got a negative. Then we do f of 6.9 we have 6.9 plus 6 divided by 6.9 squared minus 11 times 6.9 plus 28. And we got a negative. And then f of 7.1 gives us 7.1 plus 6 divided by 7.1 squared minus 11 times 7.1 plus 28, and we get a positive. So hopefully you see that that matches. We got positive to the left of 0, positive to the left of 4, negative to the right of 4. Negative to the left of 7, positive to the right of 7. So we could get the same pluses and minuses, which tells us that the y goes to infinity or negative infinity. For this question, we want to find the equation of all horizontal asymptotes, if any, of the rational function. we're working with the function f of x equals 6 over x plus 9. Now, the actual math or calculation involved in finding horizontal asymptotes involves calculus. Since we're doing this in an algebra class, what we're going to do instead of the calculation is that a bunch of scenarios or cases have been summarized for us, and we're going to memorize those different cases and be able to identify the horizontal asymptote from that summary. So we do have a little bit of memorization to do to be able to answer these type of questions. So what we need to do is know what the cases are. And in our cases, the first one is that the numerator degree is smaller than the denominator degree. In the next case, the numerator degree is equal or the same as the denominator. In the third case, the numerator degree is bigger by 1, bigger than the denominator degree. And in the final case, the numerator degree is bigger by more than 1. So in order for us to figure out which case we're working with, we have to know the degree of the numerator as well as the degree of the denominator. Now, the degree is going to relate to the power on x. So for our denominator, we have x plus 9. So let's analyze this. We have x plus 9. Each term has a degree. So this term has a degree of 1 because the power is 1. This term has a degree of 0 because there is no variable. And then the degree of the overall polynomial or denominator, we're going to take the highest of those degrees. So the degree of the denominator is 1, and we call that m. Now for the numerator, we have 6, and the degree of something without a variable is going to be 0, and it's the only term, so we know that the degree of the numerator is 0, and we call that n. So we can see here that the numerator degree is smaller than the degree of the denominator. So n is less than m in this case, and that's usually how we label this instead of with words with symbols. The degree of the numerator is smaller than the degree of the denominator. So our function is in that first case, and what we do is we memorize in that first case that the horizontal asymptote will be y equals 0. Anytime the degree of the numerator is smaller than the degree of the denominator, the function has a horizontal asymptote of y equals 0. Now, in the other cases, you have no horizontal asymptote if the numerator has a bigger degree. So in both of those cases, the numerator degree is bigger, and there's no horizontal asymptote. And in the case where they're equal to each other, you have a horizontal asymptote, and you have to do a little calculation. It's going to be y equals the ratio of the leading coefficients. That's an LC, leading coefficients. So to just put a final point here, for this particular example, because the degree of the numerator is smaller than the degree of the denominator, this particular rational function has a horizontal asymptote at y equals 0. For this question, we want to find the equation of any horizontal asymptotes of this rational function. So we're given this rational function here, f of x equals 8x squared minus 3x cubed over 7x cubed plus 4x squared minus x plus 4. Now when we're looking for horizontal asymptotes, the actual math behind finding horizontal asymptotes involves an operation called the limit that we learn about in calculus. So instead of us learning this operation that is for a later subject, what we have is a summary of different rules to handle different situations related to horizontal asymptotes, specifically for rational functions. So if we have our rational function being p of x over q of x, then it's going to be of this form here. This is a polynomial function in the numerator as well as a polynomial function in the denominator. And the rules are based on the degree of the numerator as well as the degree of the denominator. Now, the degree of the numerator is the highest power on x, and that's what we see here. It's listed as n. That's the degree of the numerator. It's the highest power on x from the numerator. And then it's also based on m, which is the highest power on x from the denominator. That's the degree of the denominator. And then what we do is we compare those values. If you have the degree of the numerator being smaller, if the two degrees are equal to each other, if the degree of the numerator is bigger by 1 and bigger by a lot, we have these different cases. So we need to determine the degree of the numerator and the degree of the denominator. So for our numerator, we can see that this term has a power of 2 on x, and this term has a power of 3 on x. The degree will be the higher of the two. So the degree of the numerator will be 3. And then looking at the denominator, this term has a power of 3 on x. This term has a power of 2 on x. This power is not listed, so we assume it to be 1. And this term, since it doesn't have a variable, has a degree of 0. So we're going to take the highest of those, which is 3, and that's the degree of the denominator. So since we have the degree of the numerator being 3 and the degree of the denominator being 3, that means that we're dealing with this second case of finding the horizontal asymptote. And in the second case, the line y equals a sub n over b sub n is the horizontal asymptote. Now a sub n and b sub m are the leading coefficients. These are the coefficients that are attached to those highest degree terms. So we want to use the coefficient of -3, which is attached to that highest term, that highest degree term of 3, and 7, which is attached to the highest degree term from the denominator. We call those the leading coefficients. So the horizontal asymptote is going to be the ratio of those two numbers. Our horizontal asymptote is y equals the ratio of -3, that's the leading coefficient from the numerator, with the leading coefficient from the denominator. So y equals -3/7 is the horizontal asymptote for this function. For this one, we want to find the equation of all horizontal asymptotes, if any, of the rational function f of x equals 6x cubed minus 7x squared plus 2 over x squared plus 7. So I've pasted some details below of how we will find horizontal or oblique asymptotes or slant asymptotes. And when we're finding horizontal asymptotes, what we know is that we have a rational function, and a rational function has a polynomial in the numerator and in the denominator. And polynomial functions have degrees. The degree is the highest power on the x. And so we take the highest power from the numerator, which is the degree of the numerator. We call that n. Degree of the numerator is n. And then from the denominator, we take the highest power. We call that m. The degree of the denominator is m. And we compare them. So we have these 4 situations that have been summarized for us using calculus. So what we need to do is we need to figure out which situation we're in with the degree of our numerator and denominator. And then there are instructions here on how to find the horizontal and oblique asymptotes based on those, that comparison of the degree of the numerator and the degree of the denominator. So looking at our function, we have the highest power on x being 3 from the numerator. So we're going to say that n is 3. The degree of the numerator is 3. And then the highest power on x from the denominator is 2. So m is 2. The degree of the denominator is 2. So we need to figure out which of these situations we're in. Which case are we in? So we have this first case where the degree of the numerator is less than the degree of the denominator. And I can see that that's not true in this example. The numerator is larger than the denominator. So we are not in case 1. In the second case, n is equal to m. The degree of the numerator is equal to the degree of the denominator. We have 3 and 2. Those values are not equal to each other, so we're not in case 2. And then we have the third case where n is equal to m plus 1. And that's where the numerator is 1 larger than the denominator. The degree of the numerator is 1 larger, and that is the case that we're in. 3 is 1 more than 2. N is 1 more than m. So this is the case that we're dealing with this particular rational function. And although it's not stated here, there is no horizontal asymptote whenever we have the degree of the numerator being 1 more than the degree of the denominator. So these instructions say to find horizontal asymptotes. So we're going to be able to say that there are no horizontal asymptotes for this function, f of x. So this graph will have an oblique asymptote or slant asymptote. You can find the slant or oblique asymptote using long division. Now that is not necessary for this question or for this particular problem, but I'm going to go ahead and do the long division just for informational purposes. So what you would do is you would take the denominator x squared plus 7 and you would divide that into the numerator 6x cubed minus 7x squared plus 2. And you're going to match x squared with 6x cubed by multiplication. So I would multiply by 6x. That would give me 6x cubed and a plus 42x. And with long division, what you do is subtract these terms from the ones above. So I would subtract these values. The 6x cubed minus 6x cubed becomes 0, so those cancel out. And then I don't have any like terms here, so I'm just going to write these down. This becomes minus 7x squared minus 42x plus 2. And then we repeat that process over again. So I'm going to try to match this x squared with negative 7x squared with multiplication. So I'm going to do a minus 7. Minus 7 times x squared is minus 7x squared. Minus 7 times plus 7 is a minus 49. I want to subtract, so I change the signs. And this negative 7x squared and positive 7x squared cancel each other out because they become 0. 42x doesn't have any like terms, so I just carry that down. And then 49 plus 42 is 51. So this is going to be the remainder. And we can ignore the remainder when we're looking for the oblique asymptote. We're just going to use what's up here. Y equals 6x minus 7 would be the oblique asymptote for this rational function. And as I said, that's not necessary for this question. I just thought I'd throw in a little bit of extra for informational purposes. Thank you for checking out my videos. Have a great day.